In this video, we're going to discuss the question, what is a differential equation? So to put it simply, a differential equation is some equation that relates an unknown function y, which depends on some independent variable, maybe t or x, to its derivatives. So you may have a y prime of t or a y double prime of t. You may have a t. All of those things are related to each other in some way. And so in general, we could say that there's some function f that relates y, y prime, y double prime, and t, and that function can be set equal to 0 or some constant. So as an example, we could have something like y prime minus y equals 0, or equivalently, y prime equals y. Here I'm leaving off the parentheses t, but the idea is the same. Y is a function of time, and what we're saying is the derivative, or the rate of change of y, is equal to the value of the function. And in this particular case, it's not hard to guess a solution. If y was something like e to the t, and you took a derivative, you would see that it would satisfy that equation. In fact, if you put any constant out front, that would also be a solution to this equation. Let's do another example. It's a little more interesting. You could have something like y double prime plus 4y prime plus 3y equals 0. That is an equation that's relating the second derivative and the first derivative in the value. And if y was representative of position, then that would be saying something about the acceleration, the velocity, and the position. And equations like that are quite common in physics, where you're trying to make a statement about how an object's position is changing over time. Now, that one's a little trickier to solve. We'll talk about how to solve that in a few weeks. All right, the last type of a differential equation that you may come across in this class is, it's going to look a little different, because instead of having regular derivatives, we're going to have partial derivatives. So in this case, y is a function not just of t, but of t and x. And so we're saying that the derivative of y with respect to time equals the second derivative of y with respect to position. So these first two examples were called ordinary differential equations, or ODEs, because we have ordinary derivatives in the equation. And those are a little easier to work with, and we'll spend about 3/4 of our time this semester working with these types of equations. This last example is what you might call a partial differential equation, or a PDE for short. These equations are also quite useful. The one shown here is known as the heat equation, and they're used throughout physics to describe problems where you have both space and time, and you need to describe how things are evolving in that domain.